Alrighty. So this is it's a parody of a Tennessee Ernie Ford tune, 16 Tons. Here we go. Some people say Bigfoot as real as they come. He's never been seen, but he's a real chum. Sighting after sighting can't all be a hoax. Only one or two were actually jokes. 16 tons, what do you get? A whole lot of bullshit on the internet. James Randi, don't you call me, 'cause I can't go. Someone's wrong on the internet, don't you know? The towers couldn't fall as fast as they did unless an inside job was done with a squib. Squibs and thermite and lasers from space makes you wonder what's happening to the human race. 16 trolls, what do you get? A whole lot of bullshit on the internet. James Randi, don't you call me, 'cause I can't go. Someone's wrong on the internet, don't you know? They say chemtrails are death way up in the air. The government has a plot to spray them way up there. And when it settles on you, you're gonna get sick. You'll twitch and moan and die real quick. 16 trolls, what do you get? A whole lot of bullshit on the internet. James Randi, don't you call me, 'cause I can't go. Someone's wrong on the internet, don't you know? Some people say the earth is 6,000 years old, and evolution means your grandma is a slime mold. And if you think Darwin's right, you're going to hell. You're gonna fry in eternity for a long spell. 16 trolls, what do you get? A whole lot of bullshit on the internet. James Randi, don't you call me, 'cause I can't go. Someone's wrong on the internet, don't you know? There you go. Alrighty then. I'm Dave Thomas. I'm going to talk about the flat Earth. And actually, most people don't appreciate this, but back in the day of Archimedes and Eratosthenes, people knew the Earth was round. The myth is that in the Dark Ages they thought it was flat. They knew it was round. Columbus was off on the radius. He thought the Earth was a lot smaller than it turned out to be, and that's why we have Indians. So I'm going to start off with a little clip from the great Richard Feynman on what is science.
Now I'm going to discuss how we would look for a new law. In general, we look for a new law by the following process. First, we guess it. Then we well, don't laugh, that's really true. Then we compute the consequences of the guess to see what, if this is right, if this law that we guessed is right, we see what it would imply, and then we compare those computation results to nature, or we say compare to experiment or experience. Compare it directly with observation to see if it works. If it disagrees with experiment, it's wrong. And that simple statement is the key to science. It doesn't make a difference how beautiful your guess is. It doesn't make a difference how smart you are who made the guess or what his name is. If it disagrees with experiment, it's wrong. That's all there is to it.
All righty. So that was Feynman basically describing how science works, and you have to assume something and then test it. Pseudoscience, on the other hand, this is a typical sort of flat Earth or maybe a geocentric perspective. But here they're saying if you just look at the sky, you can tell the Earth is motionless. Just use your common sense and to suspend this common sense geocentric perspective and assume it's the Earth rotating beneath us. That's quite a theoretical leap to take. That's what science is. You make these theoretical leaps. That's exactly what you need, something to test. So first we guess it, then we compute the consequences and compare those to reality. And if it disagrees with reality, it is wrong. So here is the first half of a flat Earth meme, globe Earth proof, just a bunch of complicated equations. Who could possibly understand that? Doesn't mean a thing. Whereas the flat Earth, you just look, it's flat. Use your eyes, open your eyes. So, and I like to invoke Albert Einstein here. Make everything as simple as possible, but not simpler. And of course, they're just going way overboard on the flat Earth end with the simplification. So this is a little bit of code for the actual formula for the length of a day and as a function of your latitude and the time of the year, day of the year. And this is just a few terms, the mean solar time, the solar mean anomaly, the equation of the center, and just look at this equation. It's got 30 terms. And that's just for a few things. You have pages of this, and it's just like that picture with all the equations on the blackboard. So to argue with flat earthers, I like to keep it simple. And so I have developed a simple sphere model, and it provides seasons and length of night and day. And I made a little CAD model to be able to illustrate it. But basically, we've got the sun. You can see that mouse, great. So this vector points down to the sun in the winter and up in the summer. And this plane here is night and day. Day on this side, night on that side. It's called the terminator line. And so in the summer, that plane is tilted back. On the equinox, it goes straight up. And so in the profile view, you can do some very simple equations. Here's the equation of the terminator plane. Latitude gives you that, and also the radial distance. This equation tells you where the sun is for every day of the year. It's just, simple. The sun's low in the winter, even on the equinox, high in the sky on the summer solstice, fall equinox, winter solstice. So you put those together, and you can see that's sunrise, sunset, and this angle alpha there just pops out of these few equations. Boom. And so you can see in the summer, from sunrise all the way to sunset, it's twice this angle alpha. Summer daytime is longer than the equinox, which is exactly 12 hours. And if you look at this equation, if the sun position is 0, that thing is 0, and it doesn't matter. Your latitude doesn't matter. On the Earth, any latitude on the equinox, spring or fall, days are 12 hours long, nights are 12 hours long. In the winter, because the sun is tilted down, it's a little shorter from sunrise to sunset, and so that angle, basically that angle is just this very simple equation, and the length of day is twice alpha over 15 degrees per hour. That's just the rotation of the Earth, 24 degrees, 360 hours. What does the wine glass signify? Well, the first time I developed this, it was years ago. I was going to a conference in Vancouver, British Columbia, and I thought, I'll just calculate the length of day as a function of latitude and time of year. So I amused myself on that flight and actually got an equation. And then it was summer. And so I calculated, hey, how long is the daytime going to be in Vancouver, which is much farther north than my home of Socorro. And I was surprised to find, wow, it's going to be several hours longer than you're used to. And then that evening, as we were sitting in the courtyard of the hotel sipping wine, watching it was still twilight at 10:30, 11 at night. I went, yeah, the day did last longer. Cool, science works. So it's not the first time we'll hear of drinking. But there's the equation, the sun equation, length of day, latitude, sun position. Simple as that. You can put this thing on a spreadsheet, and bam, there you go. So I use that to make a little chart with Python. So basically, this shows you the whole year from left to right. Those are the equinoxes. Everyone has 12-hour days on the equinox. In the summer, in the northern hemisphere, you have 24-hour sunlight. While in Antarctica, it's 24 hours of darkness for several months. We can see the farther north you get in the summer, the longer your days and the shorter your nights in the south. So this all, sort of agrees. Here is the actual chart based on the complicated math that has pages and pages of equations. And does it agree with the simple model? It actually does. These corners here have a little different, but otherwise it's pretty good. So a very simple model, the Earth, couple of math equations, and bam, there is not only day and night, but seasons. Seasons are explained because we have a lot more daytime in the summer than in the winter. In the north, pretty much wherever you are. Here is the flat Earth model. So basically, they think it's hard to pin them down. There is no official flat Earth model. But as far as I can tell, most flat earthers think the sun just goes in a circle above the Earth, 3,000 miles up, and it has a short radius in the summer, and then an equatorial radius on the equinoxes, and a longer radius in the winter. And that's how you get light down south. So this great picture of Mount Rainier shows the shadows on the clouds. The source of this light is below Mount Rainier and the clouds. That's how you get a shadow on the clouds. And so the sun can't be 3,000 miles up. It just can't. It's got to be below Mount Rainier to make that picture. So good question. So here's a little chart I made with Python. And this shows a globe picture of what's happening on the equinox, like March 21st or September 21st. So this is dawn at London, England, Greenwich Mean Time. And so the Earth is lit up on this side. Everywhere from the North Pole to the South Pole, every longitude has dawn at the exact same time on that special day, the equinox. Here is the flat Earth equinox. And basically, yes, there's the flat Earth model, and half of the Earth is lit up, as it must be, on the equinox. So my question to the flat earthers is, okay, here's the sun. It's just south of India, Bangladesh, it looks like. And it's still the setting sun. It's still late afternoon in Christchurch, New Zealand. So that's more than 10,000 miles away. How is the sunlight going 10,000 miles to get all the way to Christchurch when it's only 10,000 miles from that same sun to New Orleans, USA, and it's midnight there, total darkness. How does this sunlight know to stop at this special line? What's the equation for that? And the answer is there is no equation for that. Einstein couldn't come up with the equation for that because it's impossible. Another problem, there is the equinox as the dawn passes through my hometown of Socorro, and pretty much Albuquerque too. So to commemorate this year, I went to this East-West Street Bullock, and on the morning of the equinox, the sun rose directly east, just like it was supposed to, according to the heliocentric model. And here's my flat Earth map of the same, and this shows east at sunrise in Socorro, but at this time, the actual position of the sun is just going to be off of Dakar and just west of Africa there, and it's way far north. Instead of rising in the east, the sun would be about 30 degrees over here, so just wrong. So it, like Feynman said, you calculate consequences. So here is a little animation I made showing day and night. Here as if we were viewing the Earth from outer space. Here it is on a Mercator map, and this last one is the official flat Earth map. And all I'm doing is plotting where day is and where night is and where the sun is, that little red circle. So we can watch Greenland here. So this is in the solstice. So the very tip of Greenland has a few hours of night. Otherwise, all of Greenland, 24-hour sun. And we see over here, Greenland, 24-hour sun. Here comes a couple hours of nighttime. And we see it on this map too. There's Greenland, 24-hour sun. And then here comes just a couple hours of nighttime. Boom, right there. So, so the flat Earth model almost works in the summer. They say the sun is like a spotlight and it only shines a certain distance. And once you get past that distance, it's nighttime. It almost works. But if you take the summer solstice and you advance 6 months to the winter solstice and you add 12 hours to go from day to night, you get absolute complementarity. Where it was night here, it's day here. Everything is switched. And we have this spotlight of darkness. Now the sun creates light that goes all the way around the Earth, across, all the way to Antarctica, but it leaves this big half of Earth-sized dark hole, the spotlight of darkness. So here's the animation. And this one looks exactly like what we'd expect. The Mercator map, not too surprising. But flat Earth, we have this sun creating this big, huge swath of daylight with this big dark hole inside of it. And what flashlight does that? What beam acts like that? No beam at all. So here's the model. This is a flat Earth beam. If the Earth is flat, why don't we see sunlight 24 hours a day? The same reason why this light bulb can't illuminate the entire wall. The light is small and localized. So if that was true, if you were out here in the dark region and you had a telescope, you'd still see that light bulb. But let's see how sunrise works. Here's a picture of sunrise on a round Earth. And this person here, he's still at nighttime. The sun has not risen from his perspective, but he can look beyond him and see these clouds lit up by the sun, and it makes total sense. The sun's 93 million miles away. High things can be illuminated, whereas low things are blocked by the curve. On the flatland model, the sun is small, it's local, and if the sun is illuminating this cloud, then it has to illuminate the mountain and the person. There's no way. If it's a flashlight beam that only goes so far, then if it gets this far, it for sure goes this far. So that is a problem. So I made a little animation last winter of sunrise on a flat Earth. So here we'll see the sunrise approach from left to right, just like a beam, just like that flashlight. And on the right, we'll see as the Earth turns, the beam of sunlight comes down and lights up the high things first. So here's the animation. Flat Earth on the left, globe on the right. The clouds are going to get lit up first on the sphere model. Pink clouds, then the mountains. They lit up, and then the trees. The lower things light up last, and the house lights up last. Whereas on the flat Earth, first the house, then the tree, then the mountain, and the last thing is the clouds. So it's backwards. That's a real test. That's a science experiment. What does the sun do on a real mountain? So I've done that experiment down in Socorro. Here is looking east and west at a mountain before the sunrise, and then a little over 15 minutes later, the sun is rising in the east, and the mountain is fully illuminated in sunlight. So I've got a movie that shows that. And then in addition, I've got a Mount Rainier sunrise, a Mount Fuji sunrise, and then courtesy of Frank Etzkorn, a Sandia Crest sunset. So I'm going to switch over to videos. So you'll see the shadow of the earth. There it is, the shadow of the earth coming down the mountain. The tree is still dark. The church is still dark. And there they go. The last thing to light up are the closest, lowest objects, just like that video. Wow. Amazing. Yes, and that's a Mormon church, by the way. Okay, so let's go to Mount Rainier. See if something similar happens up there. So I'm collecting sunrise videos now. Well, look at that, from the top down. Amazing. Just like in Socorro. Holy cow. Looks like this roundness thing might be catching on. Mount Fuji. Here we go, Mount Fuji. Notice it's dark in the foreground. There it is. No Mormon church here, but plenty of Buddhist temples. And you can see it's still dark, close to the video there. Excellent. And let's do Frank's. Now this one is a sunset video, so it's backwards, of course. Okay. So this one goes from the bottom up because it's sunset. And boom, and that's the beautiful time of Sandia's sunset. There's a saying, when the mountain turns pink, it's time to drink. But I've determined that when the sun sets in Albuquerque, New Mexico, then you have about 5 minutes to enjoy that drink. So, for instance, Alameda, we are on Alameda. Just up the street here, city limit 5,000. So if you were to have somebody observe sunset there, and also somebody on the top of the Sandias, then there would be a little over 5 minutes from this sunset to that sunset. Why is that? Because in that time, here's the Alameda sunset, and then the Earth rotates to bring sunset to the top of the Sandia Mountains, the top of H, and that takes time. And what time is it? Well, the Earth turns, the angle that the Earth turns is to 2 pi, or 360 degrees. By equivalent is the number of seconds divided by number of seconds in a day, 86,400 seconds. This is the trigonometry from the diagram. Bunch of maths later. radius of the Earth approximately 2 times the height from Alameda to Sandia Crest divided by that angle squared. And you just get the angle from, I put in 320 seconds, I got 0.023 radians, 2h over that squared, h was about a mile, 3,900 miles, which is actually very close to the radius of the Earth. Very good, Frank. There are other methods to determine the radius of the Earth. Eratosthenes did a great experiment in 240 BC. You can do this anywhere. You have to have 2 locations on the same longitude. In the northern longitude, the sun will be lower just because you're farther north. So, but the assumption is the sun is 93 million miles away. This is parallel to that. And so the distance between them is to the circumference of the Earth as it's related to this angle right here. 360 degrees to that angle, the difference between the zenith angles there. So,
David,
yes.
The two towns have to be same meridian.
They do.
Yeah, we did that.
Oh, I thought I did, but yes, they should be on the same longitude. Okay, no worries. That's a good thing to emphasize. So the flat earthers say, but you're just making an assumption. You can also assume the sun is small and local, and the reason that the sun's lower at location 2, farther north, is it's just farther away. So a shallower angle to the sun, more of a zenith angle. And that's true. You can assume that. And in this case, where with the spherical equation you get the radius of the Earth, with the flat Earth approach, you get the height of the sun. And it's just some simple math to eliminate x, the unknown. Height of the sun is this distance between the 2 cities divided by the difference of tangents of the 2 angles. Boom. So that is something you can test. This is what Feynman has been asking for. Let's see the consequences. And we actually did test this. UNM had a group measure the angle on an equinox here in Albuquerque at UNM. And a team in Saskatoon, University of Saskatchewan, did their measurement. The sun was much lower in the sky, 51 degrees compared to about 34. About 1,100 miles between them. So height of the sun, about 2,000 miles. Radius of the Earth, about 3,900 miles. So yeah, you can use it. And I'm trying to organize a worldwide experiment to actually do this. But here's what's going to happen. If we have, say, 11, and I basically calculated, picked 11 cities on the same meridians and said, let's calculate the radius of the Earth and also the height of the sun. And you can see radius of the Earth is pretty consistent, just under 4,000 miles. The height of the sun is going all over. Because why? It's a bad theory. The Earth is not flat, and the consequences of flatness are chaos. Here's another flat Earth meme. If you think these sun rays were cast from 93 million miles away, you probably failed geometry. And they're implying that the sun is close, local. It's just behind those clouds. Look, the rays intersect where the sun is. And that's a total misunderstanding of perspective. So I've got a couple movies to show you, and then we'll pop back. One I made, one I didn't. This one I made, shadows. So it's just some shadows, and they start off pointing toward the sun, just like those rays in the meme. But if I go on the other side of the fence, I have to get around the little barrier, and now those same shadows are converging away from the sun. Okay, and I got one more. Somebody got a drone. I need to get a drone to do this. But here's the shadows converging on the sun. But as the drone goes up and up, they are parallel. Those shadows are parallel. And it's just a trick of perspective that makes them look so yeah, we saw in that first video, these shadows converge on the sun, but they also converge away from the sun. It's just perspective. The same shadows converge or diverge. Railroad tracks, they are parallel, but they don't look parallel. It's perspective. And lately, there's a little clip of a show, one of the British comedies, where they show a toy sheep, and the priest is trying to explain, it's small, it's close. Out there in the field, it's big. Okay. So here's a great picture of the night sky from Utah, Arches National Monument, a panoramic view and a time-lapse view showing the stars circulating around Polaris. And in the south, you can't see where they're circulating, but you can sure see they're going clockwise. So I made a model of that, continuing on the theme of trying stuff. So I just put in 3 constellations. There's the Big Dipper. Down here is the Southern Cross, and there is Orion with Sirius added. And Orion goes around the equator. I've got 3 models. The Earth is a sphere, and the stars are in a star sphere. Then the Earth is flat, but many flat earthers say, no, the stars are in a sphere. So I'm looking at that. And then a flat Earth with a flat star disk. And where are those stars? Well, the Southern Cross has to be above the southern latitudes. And the Orion has to be above the equator. So the positions of these stars are constrained by what we observe. So I have a little video for that. Here we go. So this is from the northern hemisphere. Here's our 3 constellations. The Big Dipper looks like it circles around Polaris. Orion rises in the east. It gets high in the south, and then it sets in the west. The Southern Cross, we can't see it at all. It's below the ground. Now here is the flat Earth star sphere. Orion, we never see the bottom of Orion, ever. And instead of the Big Dipper going around Polaris, it kind of goes across the sky from east to west. And of course, we never see the Southern Cross. Holy cow. Now here is the flat Earth star disk. Now we can see the Southern Cross, and it looks like the Big Dipper is going in a circle, but Orion, it does not rise in the east. Orion's in the sky the whole night. So that doesn't agree with reality. Here in the southern hemisphere, this is on the globe. Now they can see the Southern Cross going clockwise around the southern pole star. Orion rises in the east, but it's upside down in Australia. Polaris is on top. Then Orion sets in the west. And meanwhile, okay, here is the southern view of Orion. You can only see the top half still severely messed up. You can't even see the Southern Cross, and you're in the southern hemisphere. Holy cow. And here's the flat Earth star disk. So this is from like Australia, New Zealand. You can see the Southern Cross. You can see Orion. Orion never sets. That's wrong. All the stars are always visible. That's wrong. So using the Feynman test there, flat Earth is nonsense. So here are the top 300 stars. And so that's the simulation. And then we'll pop out of that. And that is the panoramic picture. There's my panoramic simulation. Looks pretty good. So I would argue that the stars are excellent evidence that we live on a sphere. In the southern hemisphere, they can't see Polaris. They can't see it at all. And in the northern hemisphere, we can't see the Southern Cross. Actually, from Albuquerque, I think we can see the highest star of the Southern Cross. If you're really on top of it, maybe on top of a mountain, yes, you can get one star of the Southern Cross. That's it. So that's a really good evidence that there's something round in between the people up here and the people down there. Oh, shoot, I forgot the microphone there. Sorry about that. Celestial navigation depends on a globe. And it gets really complicated, but the nuts and bolts is you can take 3 sightings with your sextant of the angle from the horizon to 3 different stars, and if you very carefully note the angles that you get and the times, then you can make these charts and intersect 3 circles and determine your location. And it's pretty intense math. They have big books full of formulas that you have to apply. And there are some flat earthers that say, oh yes, the sextant works on the flat earth. No, it doesn't. It really doesn't. And in fact, one flat earther challenged to use a flat earth model to show how you'd find your position with a sextant. He just used the globe model. Yeah. So here's a great experiment. Now what I showed you, that is celestial navigation. That is hard stuff. You got to be a sea captain or a physicist to really want to get down in the mud in that detail. But there is easy celestial navigation anyone can do tonight. Find the pole star, Polaris, the northern star, and just measure the angle from the horizon to Polaris, and that is your latitude. And it works anywhere. If you're at the North Pole, your latitude's 90 degrees, you're looking straight up at Polaris. If you're here at Albuquerque, about 35 degrees, Polaris is 35 degrees up. On the equator, Polaris would be just on the horizon, and in the southern hemisphere, Polaris? You ain't looking at Polaris, buddy. You can't see it from there. So you can use the flat Earth assumption to calculate the height of Polaris. So let's say you're at some city, and here's the North Pole. Polaris is above the North Pole, and you know the distance from the North Pole to that city, and you can measure the angle, the elevation of angle of Polaris. You can calculate the height of Polaris. It's just that distance times tangent of the angle. Very simple stuff. But if you actually put real data, and a flat earther actually gave me these angles, said, yeah, here's angles and distances for 2 cities. So I went ahead and calculated height of Polaris. And from Paris, it's 5,200 kilometers. From Kuala Lumpur, it's only 500 kilometers. It doesn't work. So I invented something I call Polaris land, which is a land where the height of Polaris divided by the tangent of your latitude is your distance from the North Pole. So basically you say, yes, latitude is correct, but the distance from the North Pole is going to be whatever it has to be to make the elevation of Polaris your latitude. So this red line is the traditional flat Earth map, what's called the Gleason map. That's the whole thing. South America, Antarctica, it would all be included here, but we can see it's terribly distorted. Like, look how big Mexico is, and look how big Africa is. Terribly distorted. Earth doesn't look like that. So if I zoom out, here I've zoomed out, this green circle is the orbit of the moon. Not the radius of the moon, the orbit. 239 miles. It took days and days for our astronauts to fly there in their spaceship. And at this great distance, South America is this huge chunk. This is actually very little region of South America, but it's magnified because you're you're applying this elevation rule. You're saying I have to be far enough to make the elevation of Polaris my latitude. So the Earth doesn't look like that. And this, what we saw before is that little red circle right there. Crazy stuff. So, and oh, talk about the southern hemisphere. This map goes to infinity and you finally get to the equator. There is no southern hemisphere at all. So let's move right on to Greenland, and Antarctica rather. There's the Gleason map of the flat Earth, the traditional representation. The UN map is a similar projection, and flat earthers say, see, UN knows it's flat. Wow, but the UN wanted a map to show all the continents. So Australia, a flat earther, sent this map to me to show me that Australia is about as big as the United States, and it is. This is a real map. But if you look on the flat Earth map, Australia is twice as big as America. It's not realistic. So what did the flat earther tell me when I complained? He said, great attempt at justifying your result. Of course the globe distance is correct, you idiot. We don't dispute landmass sizes and distances. We dispute the shape they're on. And therein is the rub. If you assume a flat Earth, Australia is going to be bigger than the U.S. If this is your conception of the flat Earth measured from the North Pole. You can't just... and so what this poor guy does is when he calculates the distance between Australian cities with the flat Earth map, he says, well, degree of longitude here, degree of longitude there, on the equator, 69 miles, boom. He's using the globe to calculate distance. So Australia, big problem. These heroes circumnavigated Antarctica on a yacht in about 100 days, incredible, difficult journey. They started in Africa, went all the way around Antarctica, pretty close in, and then they landed in Australia. And so I digitized their journey. That's what it looks like. There's Africa, round, and Australia. But on the flat Earth map, you start, and then you go all the way around, and then you come back. Oh yeah, you start here, go all the way around, and then you land in Australia. So 86,000 miles, where it was only 15,000 miles on the globe, you couldn't do a yacht journey of 86,000 miles in 100 days. You can't do that. So, and this is Antarctica, this white border of the flat Earth map. So the South Pole, the geographic South Pole, where they have this nice little display, it's here, and it's here, and it's here, and it's here. The whole rim of the map is this one spot. It's incredible. So to go from here to here, you're on the South Pole. You turn around, and you've done it. You've gone thousands and thousands of miles on the flat Earth map by doing a pirouette. Amazing. So the flat Earth says, "Oh, those globers are cheating," and this is a flat Earth meme. This is a different yacht race. They left from Europe. They came around Africa. And then they went between Antarctica and Australia, came around, and then went up between Antarctica and South America, went back to Europe. And so one flat earther says, "Oh, they're cheating. They're going from Europe, and then they're going down to the bottom of Africa, and then they're just going over up to South America and then back. That's all they're doing. They're not going around Antarctica. They're just going around this little tiny part." And so my question is, who cheated? Because this is the yellow path is the real path on the flat Earth map. Notice you start here, you come around Africa. When you're here, Antarctica is to your left, or Australia to your left, Antarctica to your right. Then you come up from South America on its west side and back in. Look at here. At this point, Australia is to your left, Antarctica to your right. And then you come up the west side of South America, cross over. So this yellow is the actual path. So this map is so screwed up, so bad, that flat earthers can't realize the consequences of trying to map what something looks like on a globe to what it looks like in the flat earth fantasy. Ships at sea, a great method. From a beach hotel 4th floor, my friend Robert could see this whole ship. Ground floor, we could only see the top part. And on the beach, only that tower. What was in the way? The earth, the ocean was in the way. And that link, I guess I might post this. There will be a link to the full video. Ships from the same position, as they get farther and farther away from you, they're more obscured by the curve of the earth. This ship we can barely see, whereas these closer ships, we can see a lot more of them. If this was real, the earth curved, then the Chicago skyline from Indiana would be hidden by 1,473 feet of earth curve. And they often come out with memes like this. Here's Indiana, and here's Chicago, the Willis Tower, and it is about 35 miles. And they're saying you shouldn't see Chicago at all if the Earth model was true. So always they use the wrong picture. So I found a picture of Chicago from up close and one from Indiana, 35 miles away. And then I carefully matched the heights. There's the Willis Tower. There's this tower. You can see the two pictures match up pretty well. So what have we got? The bottom of the Willis Tower, kind of like sea level there, or lake level, there's 578, almost 600 feet obscured by Lake Michigan. But we can see it here. So you can pull up a Metabunk curve calculator. I've got one on NMSR. But basically, the nuts and bolts is the round Earth is obscuring almost 600 feet. All of this under the red line is being obscured. So it's exactly what the round Earth demands. This thing is called a spirit level. It's just a tube with red liquid in it. The water comes to a level, and then you can use it to sight true level. On the flat Earth, if you were looking at a distant mountain, you'd still see it. But on the round Earth, as things get farther away, they get lower, and you wouldn't see them being level any longer. So on the flat Earth, things would look like that. On the round Earth, you'd see the mountains fall away. Here's the math for it, distance to the horizon. My uncle took this picture with one of these tubes in Malibu, California, and you can see basically the horizon. This degree actually turns out very small, 0.08 degrees, and the horizon is about 5 miles away. Whereas up in the Magdalena Mountains, there's true level. The horizon is below true level, and in fact, that's a peak that's about as high as where I was, maybe 100 miles farther east. So this shows the horizon does not rise to eye level because the Earth is round. Here, this angle, about 1.7 degrees, and the horizon itself could be 120 miles away. So we took this gadget to M Mountain, just west of Socorro, and from the top of M Mountain, we could see Sandia Crest, 90 miles to the north, and Sandia Crest is 3,400 feet taller than M Mountain. So on the flat Earth, I would be looking up at Sandia Crest, but using my level, I was looking down at Sandia Crest because the Earth is round. Here's a nice little eclipse showing shadow of the Earth. Here's one I made of the Beaver Moon eclipse. And I just put a circle of the equivalent radius of the Earth, superimposes perfectly. Flat earthers are really confused about eclipses. Throw away your NASA CGI glasses. Expose the lies. Here's one of their complaints, that the rays are supposed to be parallel, but they're not parallel here. Well, this is not to scale. And if you drew the sun 93 million miles away, those lines would be much more parallel looking. They really would. Satan and eclipses. Here's the diagram of the eclipse. Occult symbol, the seal of Satan. Occult institutions depicting the cause. So here's one the creationists did. To their credit, the creationists are frequently bashing the flat earthers because they like the prestige and just the feel-good feeling of smacking pseudoscience. They just don't like it when it's theirs. So David Rivas Ministries, they on the August 2017 eclipse, set their exposure way high, and there's the moon. The moon is what's causing the eclipse. There it is. If you ask the flat earthers, why does the sun get dark? They will say, well, it's Rahu and Ketu. The sun or the moon produces its own light. It's not a physical object. They'll tell you a million things. Why do flat earthers believe the way they do? Religion is one of the motivators. The globe, it's based in evolution, Big Bang, atheism, paganism, alien seeding, New World Order. Whereas the flat earth is in the Bible, scientifically proven, points to God, blows Satan's deceptions wide open. 4 proofs of the flat earth hotspot. Water finds its level. It never curves. Water does find its level. That's how that spirit level works. The angles, we saw that was just perspective. The horizon always rises to eye level. No, it doesn't. Big Bang, evolution, water sticks to balls. Gravity, the imaginary force that holds all together. Of course, the Masons are in on the conspiracy. Newton made up gravity, just pulled it out of his ass, and then they had to make up dark matter and dark energy to get his butt out of trouble. Here's a typical geocentrism meme. Flat earthers are geocentrists. They have to. They are obligate geocentrists, and flat earthers are obligate Apollo deniers. They can't accept Apollo because Apollo has pictures of the round Earth. So geocentrists like to point to balanced rocks and say, how could you be spinning on 1,000 miles an hour at the equator and balance something? You can't do that. Just like the guy looking at the flat ocean with his binoculars. There is no Australia. You're dumb if you think otherwise. Australia is from a Dr. Seuss novel. Kangaroos, wallabies, dingoes, platypuses. It couldn't be more obvious. Why are the natives black? It's in the Far East. A bunch of criminals came on a boat and made the country rich. I'm surprised by the large amount of sheep who've fallen for the Australia hoax. It's laughable. Holy cow. So here's the correct map. No Australia. That's the right map. Yeah. But notice, New Zealand is there. New Zealand is often left out of maps. New Zealand has a special kinship with New Mexico. Just like nobody knows New Mexico is part of the United States, nobody knows New Zealand is part of the world. So they are our sisters and brothers. There is such a thing as a free launch. You just take your spaceship to Australia, untie the rocket, and it falls into outer space. And then the engines take it where it needs to go. Simple. Free balloon rides in Sydney, Australia. So this is the flat earther conception of gravity. They think, well, it goes down, and south is down. So that's what the spherical earthers think. Of course, it's silly. Well, that is silly. This is what the globe earthers think, that gravity points toward the center of the Earth. And down from here is the center of the Earth, down from here, the center of the Earth. It makes a lot of sense. But here's the where that meme takes you. If gravity is not strong enough to stop a small stream from flowing to its lowest point, then what is stopping the oceans north of the equator from emptying into oceans south of the equator? This is what the Earth would look like if we lived on a globe. Gravity is pseudoscience, a theory that can't be proven. And wow, there it is. So it just goes south. Simple. And I have several levels, and they're all labeled wrong. Why? Because this is wrong on so many levels. So many levels. If there is no oxygen in space, how does the sun burn? Christians 1, atheists 0. They don't even know how to spell atheists. No respect. Think about it. The sun burns 600 million tons of hydrogen every second. Impossible without oxygen. So they don't understand nuclear fusion. It's not a fire. It's more like an H-bomb. If the Earth was spinning, this guy could stay right here for 12 hours and land on the other side of the planet. So as the Earth spins rapidly beneath you, of course the air spins with the Earth. So I like to point out, we had that big hurricane in Houston that parked over Houston for a couple weeks. Well, that should have come boiling over Albuquerque every day. We didn't see that hurricane every day for 2 weeks because the atmosphere moves with the Earth. Spin, 4 miles an hour. Fun, 60 miles an hour. Oh, that's intense. 1,040 miles an hour, and they're drinking tea? How can that be? But if you actually calculate the acceleration, about a quarter of a G for this one, the thing Bill Cosby said, you go round and around until you puke. These things at the state fair, man, I did one of those once. I hurt. Those are hard. Maybe 12 Gs? Probably more like 8 Gs, but pretty intense. Yes, it hurts. It's intense. And the Earth is rotating at half the speed of the hour hand on that clock. Half the speed. That hour hand isn't moving too fast. So the actual acceleration, 0.003 Gs. Have iced tea, beer, mint julep, whatever. We shouldn't see these planets from here, the night side of Earth, but we do. How can we see Venus and Mercury from at night on the Earth? We shouldn't. So, but we can see Venus for a while. So here's Venus's orbit. Here's Earth's orbit. And when Venus is as far as it gets from the sun, what we call, there's an astronomical term, elongation. Then it's a 90-degree angle here. And that's as far as Venus gets from the sun, according to Earth's point of view. And that's a 46-degree angle. So what this means is if it's sunset right here at point A, and Venus is at its maximum elongation, so 45 degrees, we can look up and see Venus. And in fact, as Earth rotates from A to B, it takes about 3 hours to go 45 degrees. And in that 3 hours, we see Venus getting lower and lower until it sets. That's when we call Venus the evening star. And then in the mornings, half of orbit later, we'll call Venus the morning star. So you can see Venus, you can see Mercury briefly, but you're not going to see it at midnight, but you can see it for several hours after sunset when it's nighttime, very dark outside. Here's a crazy moon meme. If you can explain how the Earth's shadow causes this, that'd be great. And shadows take the shape of the obstructing object, assuming that the Earth is a ball. How do you explain a half moon? Well, the problem here is that the only time the shadow of the Earth hits the moon, that's a special time called an eclipse. And they're kind of rare because the orbits have to line up just perfect. So that's not the shadow of the Earth, that's the shadow of the moon. This part of the moon is casting a shadow on that part of the moon. Same over here. So this brilliant man held up a ping pong ball to the moon, and you can see they're lit up the same. It's a ball, that's a ball. Okay. And there's a shadow. It's not the Earth making that shadow, it's the ping pong ball. Here's a size fail. Look how small America is here, how big there. The same Earth, it's all a fake. Which is the anomaly fallacy. Here's a picture Mick West took, metabunk.org. And if he's close to the globe, America looks much bigger than if he gets far away and zooms in, America looks smaller. Just like in outer space. Let this sink in. Small Earth from the moon's surface, large Earth from behind the moon. And this is a picture from the Discover satellite, which is 1 million miles away from Earth. And occasionally the moon goes between Earth and the Discover satellite. And of course, the moon's not bigger than the Earth. It's going to be smaller from 1 million miles away. Here's the same pair of pictures. Official photo from NASA. Someone, please explain to me how the Earth is 600 times bigger now. So, and one sad thing is, the David Attenborough Facebook page published a nice clean version of this picture, the Discover picture of the moon, and dozens and dozens of people said, oh, fake, obviously fake. And it's not fake, it's real. But they just wanted to join the crowd of, hey, if we can say it's fake, it's fake. So I recreated an experiment. I got a ping pong ball to be the golf ball, sorry, to be the moon. It has craters. And this blue ball to be the Earth. I had a camera either 12 inches away or 48 inches more additional, so a total of 60 inches, 5 feet. So when I was here, the golf ball's way bigger than the Earth, just like that picture from Apollo. Whereas when I'm over here, the moon looks much smaller than the Earth. It's the same. Why is the Earth 600 times bigger here? Well, because you're farther away from that small golf ball. Okay. Size and location matter. So when Elon Musk launched his Tesla into space, some Glober said, oh, that's going to settle it. But it doesn't. The flat earthers just said, that's CGI too, just like NASA. If you believe this, you are a globe-tard. Not many globe-tards posting this crap. And I disapprove. I don't call flat earthers flat tards because that's insulting to people with Down syndrome. I do use the word flurfers. That seems to be pretty popular. Can you see the curve in person? Yes, Lake Pontchartrain, Louisiana. This sequence of transmission lines, you can see the curve of the Earth. Pretty neat. Bonneville Flats in Utah, Salt Flats. The aurora. We had a recent aurora, and that was pretty amazing. And in lower latitudes, if you can see them at all, they look kind of red. And one reason is that the highest aurora are red, and then the lower ones from different atoms, different excited atoms, are kind of green and violet and blue. So another reason is with distance, the red light is not scattered. The blue lights are scattered more. So that's another reason to see these red things farther away. My friend Justin in Minnesota took this wonderful picture of the aurora there. And there's the green below and the purple above. Perfect. And I took this picture in Socorro, New Mexico. I could not see the aurora with my naked eyes, but with a time exposure, it's the aurora. Holy cow, I never thought I'd see that. So, wow, pretty impressive. And the next night, I went out, tried the same picture, nothing. This was the geomagnetic storm. It's not just an artifact of the camera. So that's the late Bob Knodel. He was featured in this Netflix movie, Behind the Curve, where Bob actually got a $20,000 ring laser gyro, tried to measure the proof that the Earth was not spinning, but it kept coming up with 15 degrees per hour drift. So big embarrassment there. And then Jeranism had a water level experiment that also turned out to prove the globe. So my conclusion, if the Earth was flat, cats would have pushed everything off by now. And the only thing flat earthers have to fear is fear itself. Okay. Okay, questions?
What do the astronomers have to say about this day?
So most of the astronomers think it's ludicrous, and you know, most of the important proofs involve astronomy. The flat earthers will say, well, don't look at the sky, look at the Earth. That's what's flat. You look down. But the reality is, you know, look at the star trails, look at the sunsets. Look up to see that the Earth is round. Joe?
Do you have any idea or know about what percentage of the Earth's population believe the Earth is flat?
So it's growing. It's alarming because basically the internet is a wonderful tool, and it makes knowledge accessible. If I want to know, you know, what's Elvis's mother's birthday, it's probably on Wikipedia. But the internet creates closed societies, echo chambers.
Do you think it's about a quarter of the population by this time?
I think of the, it may be like 10 to 20%. I mean, it's growing larger, but there are lots of resources, and it's really hard to measure. So in our history, we actually had one flat earther come to NMSR. We tried to ask him a few questions. So it's hard to tell on the internet. Are they just, you know, yanking chains to provoke reactions? So there's three kinds of pseudoscientists. There are just people that go along for the ride. They say, "Oh, that can't possibly be real," and share it, and they aren't thinking it through. So that's sort of the casual, sort of lazy, stupid pseudoscience. And then you have your the snake oil salesmen that know that it's bunk, and they're making a buck off it with videos or you know, Twitter hits or what have you. And then the third category is the true ideologue who is committed to this idea, and basically any flat Earth evidence will be ignored, or contrary evidence will be ignored. So I think you know, most flat Earthers would fall in that first category, sort of casual. They haven't really thought it through. There are, you know, a small minority of ideologues that will never change their minds. But there's an interesting experiment happening right now called The Final Experiment, and a YouTuber is hosting an expedition to Antarctica, and it's through like real Antarctic outfitters like Union Glacier Camp. So he invited 25 globe earthers and 25 flat earthers. The idea is to go to Antarctica and then to witness the 24-hour sun which would disprove the flat Earth. And there are numerous flat earthers that say, oh yeah, it's impossible, it can't happen. I want to go to Australia or Antarctica to measure it. But now that it's actual reality, like Flat Earth Dave at DITRH, he's been whining about wanting to go to Antarctica. And he got the most votes of all the Flat Earth YouTubers. So the guy said, okay, Flat Earth Dave, you're going to Antarctica. And he said, no, I don't trust you. I'm not going to go. And no flat earther is going to go. And that tells us more about flat Earth than the results of the experiment. It basically says flat earthers don't want to go because they don't want the answer, because in their hearts, they know it's not flat. Yes?
I hate to make this longer, I know we're running over, but if you could tell me in a minute or two, a lot of the stuff you presented, everything you presented, the math of pseudoscience of flat Earth was northern hemisphere centric, because if you do the same thing for the southern hemisphere, it turns into...
It's much worse in the southern hemisphere, yeah.
In the southern hemisphere, we have people. Are none of those people in the southern hemisphere flat earthers, or do they have their version of it different?
They have flat Earth in the southern hemisphere. They do. And one of the groups I'm in is called, it's just for real world experiments where people will go out and measure where is the sun rising on the equinox in their city. And so every time a flat earther from, say, New Zealand or Australia enters that group, the leader from New Zealand says, okay, you're a flat earther and you're from the southern hemisphere. We have some experiments for you to try. Are you willing to just measure the sunrise? And they don't do it. So they're out there. There are southern hemisphere flat earthers.
Are they coming up with maps that look completely opposite to the ones that you were showing?
No, it's mostly. It's like the Islamic creationists copy off the American creationists. The southern flat earthers copy off the northern flat earthers. They don't make their own maps. Yeah.
It would seem one of the more compelling pieces of evidence is the fact that a disk has a gravitational field which is orthogonal to a sphere. And so if you're living on a disk, your gravity should be towards the center of the disk.
Yeah, and we'd all have to be walking like this.
The gravity is this way.
Yeah.
So how does the flat earthers...
So one of my goals is to make a video explaining that if you have an infinite flat Earth, you can use Gauss's law and you come up with normal gravity. And in fact, you can use the gravity constant that we measure and the density of the ground to calculate the thickness of the flat Earth slab. So I want to make a video as Dr. Heinzfagel or something explaining, yes, flat earthers have an explanation for gravity. Just use Gauss's law. It's brilliant. And then see if that takes seed.
I assume infinity.
Yeah. Oh, yeah. It would have to go out to infinity, or else you'd have those edge effects. Yeah.
All right, I hate to interrupt.
Okay.
We're running behind schedule. The next one up is going to be a panel discussion. First of all, thanks to Dave.
All right. James Randi, don't you call me, 'cause I can't go. Someone's wrong on the internet, don't you know?